Hello guys, welcome to the Einstein channel. As you saw from the video title, today we will talk about the lignin function. This is the function. It basically looks like a normal function, but there's so much to it. I have made this function myself. This function has many usefulness. It can be used to calculate the value of pi also, like minus 2i into ln I. So I is the iota, the undefined number, and the root of -1. So if I put the value it won't come, but I can show you a real tutorial. So here I go on to Google and I search for minus 2i into ln I. So as you saw, this is the exact value of pi. So we'll talk more about this function. So it can be taken as the equation of a trajectory also, but with air resistance, as it is not symmetrical from the top height. But after I did research and put this as the equation of trajectory, I found that the angle at which it needs to be thrown does not exist. Theoretically it does not exist, but as we can see some angle here, but when I put in the formulas this angle does not exist. So this is some good function, and this has ending point at 1, and then we have the whole, it goes down till infinity, negative infinity say. So let's do one thing, let's calculate its derivative. So I will go to functions here and let's see where do we have the derivative. Yes, here it is. So we put in the values minus 2x ln x. So I need to calculate the value. So here is the derivative function of this. Wow, it looks amazing as you can see. These both look symmetrical little bit, but they are not. They may look like, but they are not symmetrical. This is just the slope of the graph. So like at 1 we have the slope of this one, and they intersect at 0.7. That's good. So what if we take the inverse of this function? So x is equal to minus 2y ln y. So let's take a look at this one. Let me cross this derivative function. Wow, oh my god, this is good. They are perfectly symmetrical along the x is equal to y function. Wow, this makes a good shape. Okay, this is a good shape, good one. It looks like a tool that we use to strum the guitar when playing it. Basically exactly the same shape. So we talked about the inverse of this function. So now we will talk about its area. So let's go to the integration, and here's the integral sign. So I will calculate it 0 to 1. Let's see what are the results. Let me copy the function from here and dx 0.5. Oh my god, can you believe that? Integral of this function from here to here, I mean the area basically, is half. So we have got a new definition for 1/2, this function. So it is very good idea. It may not look like half, but it is half. The area is half. What if we extend the boundaries? So extending would be like from here to 2, it would give us nothing, as the integral is always above the x-axis. The area is always above the x-axis. So this is 1 by 2. This whole area will be 1 by 2 above the x-axis. So we cannot calculate the bottom area because it goes up to infinity. So I will give you a basic overview from the top of this function. So it becomes a straight line, looks like a straight line basically. So what if we remove the minus sign? Let's remove the minus sign. Well, the equation just flips. We know that the equation flips. Now area will be minus half, obviously. So minus, let's do it. Okay, let's go to Symbol Lab now. Let's now close it. Now we will find the maxima or minima of this function. So let me type the derivative. Minus 2x ln x. So this is a very good function, I'm telling you. It can calculate pi also. Amazing function. I will show you the proof that it can calculate pi in my other video, because that is too long for this video to contain it. So okay, this is the derivative. Oh, same graph. Wow, same graph we got. So this is basically the derivative. Minus 2 into ln of x plus 1. So minus 2 into ln of x plus 1. So let this be 0. So let's calculate the value, what it might be. Value of x . 0.36. Oh my god, can you see that? 1 by e. So let me engage the real function. So there is 0.368 as you can see, and so here it is a little bit approximation. So you can see this is an amazing function. It has its maxima at 1 by e. Can you believe that? A function that has its maxima at 1 by e. OMG, this is truly marvelous. Oh my god. So let's talk about another thing. So I have created another function from this function. So this function was called the Lignin function. So what about I made the Lignin Zeta function. So let's type this one, Lignin Zeta function. So it is basically minus 2x ln x into log of minus 2x ln x. Let me close the bracket. Wait, let me use the parentheses here. Wow, can you believe it? The function, can you believe this function? It extends from 0 to 1. Lignin Zeta function. It has its maxima at 2 points. See, these are basically the same points, just with different x value. So this is an amazing function. I will talk about the Lignin Zeta function more and its derivative. So this was just the video for the Lignin function. That's it guys for today. Thank you. I hope you enjoyed the video.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.